Hello everyone. In this video, I am going to walk you through this question. Question SQ1 of our special supplemental exercise. So you are given an Hertzian dipole antenna and it is vertically oriented. The antenna is the height of the antenna is 2 lambda above the infinity ground plane. So you are asked to determine all the nodes and you are given the formula. And this is the usual formula for the magnetic vector potential of a Hessian dipole. So we can start now. So let's copy this question. Let's copy this formula. So you got E beta and this is equal to J I naught L K and then E and then J K R and then sine beta and then 4 pi R. So to begin with, let's isolate the terms that has variable R. We need this variable. Yeah, first of all, before doing anything, let's draw the diagram first. So let's take a look in the cross-sectional view. You have an antenna, and this is the Hertzian dipole antenna. This means it is an electrically short antenna, very short, and the height here, according to the question, is 2 lambda. And obviously, you radiate out the electromagnetic wave, and because you are not very far away from the ground, you will have a reflection and you will form an image. Now let's say the antenna is the orientation, the polarity of the antenna is moving, pointing upward. So if you draw an electric field, then you will end up with a tangential electric field pointing this way. So in order to make sure the tangential electric field on the ground is zero, then you will have an opposite one to counterbalance this one. So as a result, you will have a image antenna below the ground in this manner. So this is the ground, infinitive ground. Now we are going to work out the combined effect of the real antenna and the image antenna. The image antenna also has its role, so it will also produce a radiation pointing to the target. So suppose the radiation from the real antenna has a pathway R1 here. Then the image antenna has another pathway R2. And let's take a viewpoint with a middle point. You will have a combining effect represented by the midpoint and the pathway of the electric field will be given by R here, yeah, this vector. So let's say this is the angle of elevation. So if you draw a perpendicular projection onto the middle pathway, and you will notice the pathway above R1 here is greater than R by this little amount. Sorry, is smaller than R1 is smaller than R by this amount, and this amount here, if my understanding is correct. Uh, so this is beta. So beta, so the height here is two lambda. So the length here will be d x cosine beta. And similarly, for uh, this one is longer than the middle pathway by the similar amount, and this one is also x cosine beta. So we are making use of the information from this diagram to derive the total electric field, and this will be the array factor. So now let's take advantage of this equation. For the upper pathway, where the pathway is given is labeled as R1, we have E1, and this is equal to L, K, and then I'm trying to change the order. So we get this E, K, K, R1, and then R1. And for the bottom pathway, we have E2, J, and then theta, L, K, sine, beta, and all these terms have nothing to do with R. I will isolate this, and then we will get K R of 2 and then R of 2. So this is the representation of the electric field E1 here and E2. E2 is the electric field due to the image antenna, and the combined electric field will be equals to E1 plus E2. And in this case, yeah, you can say for sure it's equals to I naught L K sine theta and divided by 4 pi. And then here, these two terms add together. So E K R1 over R1 plus E minus K. I need to clean up this area. K R2. Now, in this case, what we need to do is we approximate in far field when the target is very, very far. R1 is not very much different from R2. So at far field, R1 is more or less equal to R2 and more or less equal to R. But we use this approximation for the magnitude only. In terms of the electric field magnitude, they are similar. So we use this for magnitude approximation. We don't use this for We don't use it for phase approximation. So what is phase? Yeah, the index, yeah, JKR1, right? This is phase. For phase, we have to make it as precise as we can. So R1 is equals to, according to here, is R minus H cosine theta, where H is equal to 2 lambda. And R2 is this pathway, and this plus this little amount. So we are now trying to evaluate the phase. So we have to make the precise. So cosine theta. So we are going to substitute this into the equation, but we don't make it too precise for the magnitude. We make it. We make sure it is precise for the phase. So the fulfill for phase evaluation. So in this case, R1 and R2, so we are going to substitute this value into equation 1. So we substitute so E of T is equals to this chunk of expression and K sine theta and 4 pi. And now for magnitude approximation, R1 and R2 are almost the same, and they are equal to R approximately. I mean, for phase, we make it as precise as we can. So what is R1? According to here, R1 is H cosine theta, and then plus E K R plus H cosine theta. So this is the other way. Now we are now very close now. We need to simplify this expression. So what I'm now trying to, I'm going to erase the upper part of the right box. So let's make it like this. So according to here, you can extract the common factor of these two terms out of the bracket. So E of T is equals to J theta I naught L K sine theta, and then 4 pi R, and then we extract one term here, and you leave the other terms behind. So J K H cosine theta. So this is plus, and this one minus. So this is what we get. And fortunately, we can simplify this expression. We can divide this expression by 2 and then times 2. As you know this is cosine something, yeah? So J theta I naught L K sine theta, and then 4 pi r, and then k r, and then this one is obviously cosine k h cosine theta, and then 2. Yeah, we're done here. You write it clearly. So 2 cosine k h cosine theta. So this is the array vector. We are going to, the question asks for the nodes, all the nodes. So immediately, nodes means the angle which give rise to zero elliptic field. So first of all, in this expression, we have two terms containing theta. The first term here is sine theta. The second one is cosine theta here. So we need to, any term, if sine theta is 0, then you will get a node. If cosine theta here is, if kx cosine theta here is pi over 2 or 3 pi over 2, then you will get a zero elliptic field as well. So this is something that you have to bear in mind. So now I'm going to clean up the whiteboard. And I'm going to continue. So we use this term E t equal to 0 when sine theta is equal to 0. So hence, we have a node. We have nodes on 0 degree. 0 degree, and also 180 degree, and also 360 degree if you like it. So another rule is given by here. So E t is also 0 when cosine k h 2 theta is equal to 0. This means k h cosine theta is equal to plus or minus pi over 2, plus or minus 3 pi over 2, plus or minus 5 pi over 2, plus or minus 7 pi over 2, plus or minus 9 pi over 2, blah, blah, blah. So we have a lot to do. So what is h? H itself is equal to the height. The height is 2 lambda. So this means k is equal to 2 pi lambda, and h is equal to 2 lambda, and then cosine theta. And then the terms of value, right? you can name. So we can try this first. Yeah. Let's clean up this one first. Yeah? Lambda, then got the 4 pi cosine theta. And the right hand side of the equation is equals to a log of value. We can try this one first, plus or minus pi over 2, and hence pi. So we get the cosine theta equals to 1 over 8 plus or minus 1 over 8, and hence we do a little bit of calculation. According to my calculation, theta here is equals to 82 or 97. Okay, so this is we have done one, and then we continue the process. So 4 pi cosine theta is plus or minus 3 pi over 2, and hence this means theta here. I have done my calculation. Is equal to 112 or 67 degrees, and we can continue with the process cosine theta, and then plus or minus 7 pi over 2, and then let's check this one. And my calculation, according to my calculation, sorry, 5 first. According to my calculation, I got 51 or 128. So you just continue with the process until you have no more solution. 7 pi over 2, and this means theta is equal to 28 or 151 degree. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 nodes, right? The answer is almost exactly the same as the proposed answer. Okay, so if you have further questions about this, please let me know. Please leave your question to the comment section. Thank you. Bye bye.